If you are also looking for professional certified structural engineering services or courses, then don't forget to check link in description of this video.
Hey guys, welcome back to another tutorial. In this tutorial we are going to talk about meshing of area elements, and then we will be moving towards assigning the restraint to our structure, and at the last we will be discussing loads. So let's start with the meshing. So see, if I talk about meshing, so it's a quite important step if you want the accurate analysis. The more finer your mesh is, the more accurate your analysis will be. But be remember, do not make your area elements too fine, otherwise it will take too much time for doing the analysis. So there is an optimum limit of mesh size, which we will be also discussing in this video today. And do remember this thing, one more thing: whenever you see, if you have a slab or any area element, and in that slab, if any element is passing through that, so you need to make sure your slab should be meshed at that point for effective load transfer. So basically the purpose behind meshing is effective load transfer. And always mesh, this is the correct way of meshing, and this is not the correct way of meshing, because basically by doing meshing, what we are doing, we are transferring the load from one joint to another joint for an area element. So that's why if you do not do mesh, your load will not be transferred at all, and your analysis results will not be accurate. And also make sure you meshed in a correct way. Now what is the optimum size of meshing, I will be telling you in this video. And then make sure, another thing, if you have any frame element that is passing through the slab and your slab is not meshed at that frame element, so your slab load will not be transferred to that frame element. That is not a good thing. So guys, that's all theory that I have discussed about meshing. Let's proceed towards our model, and first we will be meshing our walls. So what I need to do, I need to go to, just make it by color general sections. Okay, now what I will be doing, I will be going into select, then properties, then area section, then I will be selecting my core walls as well as my basement walls. Now once I have selected them, what I will be doing next, first I will be showing you how to apply the manual meshing. I will be going into edit areas, divide areas. Now as I told you in the beginning, that I will be telling you that what is the optimum size of meshing, by following which you will have accurate results, as well as your analysis will not also take much time. Okay, so the optimum size for if you are dealing with an FPS system, so it's good to keep the size of 4 feet by 4 feet of your mesh element. And if you are dealing in MK system, so it would be good if you keep 1 meter by 1 meter. So you need to divide your area into object of maximum size 4 by 4 feet, means your each square would be of 4 by 4 feet. Click OK. Now as here you can see clearly, or let me previous selection, click on previous selection and turn off other elements. Show selection only. Oh, why? Show all. Previous selection. Okay. Show selection only. Why I'm not seeing? Okay, what I can do is I can go to select again. First show all, then go to select and select properties, and its area section, select the walls 8 and walls 12, close. Now show selection only. So here you can see we have effectively meshed our walls as well as our basement wall as well as our core walls. Now after doing that, what we will be doing, we will be meshing our slab. So which I will do, select properties, same is the concept as we discussed for walls, then area elements, wall slab 7, you select your slab, then edit area, divide areas, into 4 by 4 feet. See, it's taking time. If you keep it 1 by 1 feet, it will keep on running, and it will be, your model will be quite heavy. Okay, so see, we have also meshed our slab as well. That's good thing. Now what next we need to do is what is the next thing that we have to do? What is the next thing that we have to do? Yeah, as I told you in the beginning, that sometimes it happens you have a frame element crossing your slab, so you need to break your slab at that point. Yeah? So how you will be doing that? I'm just telling you, I'm not doing in this model, but I'm just telling you. Let's say this is your frame element and this is your slab. And first let me show you how to merge slabs, two slabs. Let's say I have to merge these 5 slabs into one. I will go to edit area, merge areas. See, now I got the one element. And now what I need to do, I have to, and let's say what I have to do, let's create a one beam in between that and show you how to divide using the frame. Okay, so now here you can see this is the frame, this is the shell element, and this frame is passing between that, but the shell element is not broken over here. So I will click both of these. I will go to edit, then edit areas, then divide areas, then divide areas using cookie cut based on selected straight frame objects. Now click apply. Now here you can see your slab has been broken into 2 points at this frame. So that was what I was telling you about. Okay, you can also break the slab at the selected point objects. Okay, if you want to learn these all concepts in detail, so go and check out our SAP2000 course on Udemy, whose link is given in the description box below. In that course we have discussed in detail about the meshing, so I will not waste my time over here on this thing. You can go and watch out that over there. Now what I need to do next is, I have done meshing of walls and slabs. Now what I will be doing next, I will be assigning the support, that is restraint support, joint, assign, joint, restraint. I have to assign this to my bottom. So what I will be doing, I will be going onto my XY plane. Let's go to 0, z equal to 0. Okay. Oh. So finally we are at z equals to 0. What I will be doing that here, I will be selecting the points. 48 point. Oh, it's 108 points selected. Why? 180 points. I need to select 48 points. 48 points I have to select. So what I will be doing, I will be going into view, or I will be going into view, set limits, see this option works or not. So z axis 0 to 210 feet. No, it should be 0 to, let's say, 2 feet. Click apply. And now if I select the points, again 48 points are being selected, which I don't want to. Click apply. See, again, so I don't want this thing. First default values, click apply. And now what I will be doing, I will be selecting these points one by one. That's all. Or let me see another way. Go to there, 3D. Okay, what I will be doing, yeah, only these points are selected. That's great. Okay, it's fine, because we have, since we have let me see, just let me turn off the slabs first, area elements, so I can have better view what is being selected and what is being not selected. So not in view, Also beams, also frames I don't want. Where is frames? Okay. So here you can see he's selected even those points, which I don't think so. They should be assigned restraint because because see the reason why these all points have been selected because we have walls, and since we have meshed our walls, so at every point now we have to assign the what you can say the joints, the restraint joint restraint. So that's good. Previous selection. I don't know why previous selection option is not working. So again go to XY plane. You have selected these 180 points. That's good. Okay. Now go to assign, joint, restrain, fixed. Click OK. Good. You have assigned your joint restraint. Now click on show all, and now we will be talking about loads. So let's talk about loads because we have meshed our area elements. There's another way of automatic meshing, which I will recommend you go and check out our course on SAP2000, in which we have covered these things in detail. The link is in the description box below. Now let's move towards loads. So the very first thing for defining loads you need to do is define the load patterns. So our first load, dead load, its type is dead and its self-weight multiplier is 1. Now why we keep the self-weight multiplier 1? It means this load pattern will take into account the self-weight of the structure. If I make it 0, so this load pattern will not take into account the self-weight of the structure. So it's always recommended to keep this factor 1 for this dead load. For other loads cases, we won't be taking this self-weight multiplier as 1. Instead of that, we will be making it 0. So let's move towards our another load, that is live load. Now these dead loads are what are dead loads? Let us first see that, then come to this applying loading. So dead loads include finishes. Usually we take 36 PSF as per ASC 716. Then partition walls. These are also considered dead load. Cladding and other superimposed immovable loads. The loads which cannot move. Those loads are considered dead loads. And we also have live loads. Live loads like occupancy load. Sometimes furniture can be considered as live load because they can be movable. Then we have lateral loads such as winds and seismic. We will be also having a separate video on winds and separate video on seismic load. And if you want to learn in much detail, so you can go and check out our course on whose link is given in the description box below, the Udemy course. Okay, so and we will be using in this video, I will be using ASC 7 for applying loading. You can use other loads too, as the IBC, UBC, Chinese or Indian standard. So as I told you, let's move back to our SAP model. Let us first define the dead load we have defined. Then our live load. Its type will be live. Self-weight multiplier by 0. Click add new load pattern. Then super dead means our finishes. Finishes load. Type is super dead. Keep it super dead. I can't find super dead. Oh, yeah, it's super dead over here. Self-weight multiplier 0. Add new load pattern. Dead we have defined, live we have defined, finishes we have defined, then earthquake. EQX. Well, I am not defining the load pattern for earthquake in this video. When we will be discussing that, in that video we will be defining the load pattern for earthquake. Okay, so that's all for our dead gravity loading, dead, live, finishes. Click OK. Yeah, wall load. We also have wall load. That will also be super dead. Click OK. Now once you have defined your load pattern, so load cases has been automatic generated. Okay, we will be also discussing this, what is mean by model analysis in detail. Okay, click OK. Now go to define load combinations. Now let's come to this step after assigning the loads. So first what I will be doing, I will show you which loads I'm going to assign.
So guys, these are the loads that we are going to assign to our model today in this video. So let's start with the very first, that is self-date load of the model structure. Now guys, I have already told you that we have incorporated this load when we were defining the load pattern. So at that time, what we did, we keep the self-weight multiplier for the dead load as 1. So what does it mean? It means that dead load will take into account the self-weight of the whole structure. So that's the load that we have already defined in load pattern by keeping the self-weight multiplier as 1. So as far as remaining loads are concerned, so we will be applying this 40 psf finishes on normal floors and 20 psf finishes on roof. Similarly, 50 psf live load on remaining floors and 20 psf live load on roof. And on beams, we will be applying the load of the walls. As we know, in RC framed structure, the purpose of beams, except shear walls, I am talking about masonry walls. Okay, not shear walls. The purpose of masonry walls is to just make the partitions. So, but they carry weight, they have their weight. So their weight will be transferred to what? Their weight will be transferred to beams. And how to transfer their weight? So it's quite simple. You should know the density of your material of your bricks or material of your wall. Let's say they are bricks. So multiply the density of bricks with the thickness of the wall and then height of the wall. Let's say, let me take you over here. Now here you can see, let's say this is your wall, this is your top beam, this is your bottom beam. Okay, so this is the height that you are going to multiply with the density and then multiply with the thickness of the wall. You will get the wall load in pound per foot, which you will be applying on the beams. So here in this case, we are going to apply 800 pound per foot load of walls in perimeters of beams of floors and 300 pound per foot load of parapet walls on parameter beams of roof. So on roof beams, we are going to apply this 300 pound per foot, and on remaining beams, perimeter beams, means the exterior beams, we are going to apply 800 pound per foot. So let's go back to our model. So this is our model. First, let us assign the floor loads, the area loads. So for which, what I will be doing, I will be going into select properties, frame sections, and then I will be select properties, area sections, slab 7. Now once I have selected all these slabs, what I will be doing, I will be clicking on show selection only. Now once I have clicked on show selection only, so what I have to do right now, I don't want to assign the loads to this top floor as its roof. Okay, it's a roof. I don't want to assign I have to assign separate area loads for this roof and separate area loads for the rest of the floor. So what I will be doing, I will be going into view, and I will be keeping the set limits. I will be clicking on the option set limits, then minimum 0, and I will be keeping the maximum as 210 minus 12, so it's around 198. So I will keep it 198, so that so that this floor the roof should not be visible to me, and then I can select easily select those slabs which are below the roof. So click apply. Now as I click apply, so here you can see can see now my roof is not visible to me. So what I will be doing now, I will be selecting these slabs. I have selected the slabs and I will be going into assign area, then area loads, then uniform shell. And what load we have to assign? We have to assign 40 psf as finishes load and 50 psf as live load. So let's go back to our model. Finishes 40 psf. Click on load direction should be gravity, 40 psf, replace existing loads. So we have assigned the finishes load to our slabs, our floor slabs. Then live is how much? It is 50. Click on again replace existing load. Now the reason I'm clicking replace existing load is because I have the separate load pattern for finishes and live. Okay, you can either click on add to existing load. Since the load pattern is changed, so nothing will happen. Okay, you can select any of these until now. Let's say if I have added 50 now and I want to add more 50, so I will be coming on add to existing load. But let's say if I kept 56 and I want to make it 60, replace it with 56 with 60, so I will be clicking on replace existing load. But for now, since there is still no any load assigned to live load pattern, so we can use any of these options. Just previous selection, click on previous selection, click apply. So our live load has also been assigned to our slabs. Now let's go and check it out whether we have assigned it correctly or not. So I will be selecting one area element to make sure I have assigned it correctly. Loads, see live 50 psf, good. Then finishes 40 psf, good. Click on OK. Now what I will be doing, I will be again going to set limits. I will be keeping minimum as 198 and maximum as 210. So I only see these, I want to see only that top roof slab. So again, let's keep it 200. Now I will only be able to see the top one. Now I will select this top one easily. Let me see that. Okay, go to 3D, clear selection. Okay, rotate it, because I want to make sure that nothing goes wrong. So hopefully I have selected the correct area elements. Now if I want, I can keep I can view the complete whole building. Okay, so here you can see we have just selected our roof slab. Click on close, go to assign area loads, uniform shell. For live, how much you have to assign? You have to assign for live 20 and same for the finishes 20. So live 20, make it 20, replace existing loads. Then again go to previous selection, finishes 20 psf, replace existing load. Okay, so we have also assigned load to our roof slab. Let us just confirm it whether we have assigned correctly or not. Then we will be moving towards applying wall loading. So here you can see 20 psf has been assigned to roof slab. That's good. Now what we have to do next, on all the floors parameter beams have to assign the wall load as 800 pound per foot, as here you can see. And for the roof walls we have to assign 300 pound per foot on the parapet walls, or parapet walls load. Okay, on the roof beams 300 pound per foot will be assigned for the parapet walls, and for the remaining floors we will be assigning 800 pound per foot of walls. Okay, so the guys, very first thing that I am going to do before applying the wall loads is I will be turning off my area elements. I will be turning the view off, area not in view. Click apply. Then since I don't want I don't want these columns, so what I will be doing, I will be going into select. I will be selecting the properties, frame sections, B10. Okay, show selection only. So now guys, here you can see we have just our beams element, no column, no area elements. Now let's come to our XY plane, and then we have to assign on the parameter beams. So let's select it. It's quite easy to select. Just watch how I'm selecting these parameter beams. Now since I have to select for all the floors, so it would be difficult if I go on doing like this. It will consume my time. So what I will do, for my convenience, I will be going to name display and let me select these beams, and then I will turn on 3D and see what beams I have been selected. Go to 3D. Okay, I have selected these beams. That's all. That's what I wanted. So again, go to the okay, but remove the selection. Okay, just select these beams. You have selected these beams. Go to assign frame loads, distributed, wall loads, gravity, force, load type force, and how much? 800 pound per foot. How to calculate this load? I have already shown you the way. Click OK. Now for this, how much we have to assign? We have to assign 300. Select these top one, go to assign, frame loads, distributed, make it 300. Click apply. So guys, see, you have applied the walls load to your beam. So this is how you have to apply the wall loads to your beams. I'm not applying on the remaining beams. You can do by yourself. I have told you the way how to do that. So that's all for today, guys. We'll meet you in the next video. Till then, goodbye.